Hi, and welcome back. And for new viewers, my name is Helen Roth. I'm the CEO of VIA, Vital Infrastructure Arena in Norway. I'll be hosting this parallel session on digitalization. Now we are going to have a new presentation on Tunnel Digitalization Center, Digital Services for Tunneling Maintenance, by Klaus Wachter for Scaut Association, and Veronika Petschen is also supposed to be there. But Klaus, maybe you should start the presentation. Yes. Go ahead, Klaus. The floor is yours.
Okay, thank you, Helen. So hi, everyone. My name is Klaus Wachter. I'm the Managing Director of the Swiss Center of Applied Underground Technologies, Scaut, and together with my colleague Veronika Petschen from Amberg Engineering, we will introduce you to the Tunnel Digitalization Center and focus on digital services for tunnel maintenance. So what is the Tunnel Digitalization Center? Basically, it's a demo center of a digital tunnel live at Hagerbach Test Gallery in Switzerland, where we can showcase all the infrastructure and installations, both in real at one-to-one scale, as well as their digital representation. So the focus is on cross-phase and cross-divisional system solutions and achieving thereby digital continuity. By demonstrating the interaction and transformation from real to digital, we can give a better understanding of complex processes and procedures with the goal to point out, but also confirm the added value of digitalization over a tunnel life cycle. By building a partner ecosystem, the TDC provides the perfect R&D environment for the development and testing of different use cases, and at the same time to showcase the solutions to partners and to potential clients. But now let's focus on the challenges we obtain in today's maintenance processes. The operator has to secure a high availability of the tunnel system without too much disturbances. We all know that money is a very big challenge, as these costs are very cost intensive. We always also have the problem of missing data, missing information, and if we maybe find them, we cannot process them since they are available in different formats or on different services. Another challenge we face with digitalization is the amount of data, especially if we include dynamic data coming from sensors, real-time data. And last but not least, the portfolio and the asset management is a challenge with all the different stakeholders as involved. So my colleague Veronika will now present you a solution to tackle these challenges. Veronika?
Yes, do you hear me?
Yes.
Loud and clear, Veronika. Go ahead.
So, I present very gladly the solutions that are the answer to these challenges, because as tunnel refurbishment specialists, we face these problems on a daily basis. That's why we were more than motivated to find solutions that digitalization could offer to us. Basically, we started with creating digital twins. Why? Because we are sure that that's a very efficient way to gather all the relevant informations into one source. And with these three-dimensional models, we can get to the needed information in a intuitive way that visualize the information that we need to make quick decisions. Obviously, no data is useful that cannot really harmonize with the fact that we construct tunnels for 100 years, so we are obliged to work in open source. We also developed tools that ease the difficult modeling of irregular existing structures, and automatic and semi-automatic edge detection helps us to resolve these questions. And we use artificial intelligence to enter the damages that we observe. So let's go a bit more into the details. What we expect from our digital twins and what we consider by the making of them, that it doesn't have to be only able to gather together the discipline-specific models, but it have to be able to be connected to other databases and cloud systems and be fed by real-time information such as sensor information, IoT, the last updates as fast as possible. In the case of maintenance projects and the digital twins for the operational phase of the life cycle, we have to transform real to digital. The documentation of the constructions doesn't always exist, or they are not complete. So the best basis is still the scanning for modeling. There are obviously invasive and non-invasive investigation methods to find out what's behind the walls. But what the real challenge was that the software industry wasn't really ready when we started with our first pilots in order to make SBIM modeling. So that's why we had to develop our all specific scripts, create our own objects libraries, and we do semi-automatic edge detections since a while already in order to optimize making the tunnel profiles. But I'm really happy to announce that the first test of our object detection tool working very well. So we can use much efficiently parametric design also in case of SBIM modeling, which is a huge step forward. The typical informations that we can use for SBIM modelings, what we can really need by maintenance projects, there are the clearance profile analysis, very important, inspection data, surveying data, groundwater analysis, a link to the maintenance plans, information about the railway or road installations, the grayscale pictures or photo documentations, but the list could be obviously very low. Where we have really fun if we can start to work beyond BIM. What does it mean? Digital twins of tunnels are already very useful for one specific projects, but tunnels are mostly part of an infrastructure network. So there are many tunnels, and the whole infrastructure, I mean the railway infrastructure could also have a digital twin. So that's why each and every element and data has to be georeferenced. They can be put on a GIS platform. So in an interactive digital map, you can have the overview of your BIM models and digital twins and just switch among them. But what makes it really useful if you can create of your different digital information dashboards that are adapted to your needs. And for example, in this particular example, you can see on the left of the dashboard some sensor information of a construction site just close to a tunnel, from which you can see the geology model in the middle, and on the right the number of online sensors. So you can evaluate the information that you want to put from them. Another example for such a dashboard, at this time with the portal of the same tunnel, but on the left you can see inspection information. The different colors of the different zones had different meanings. Green is green light. It means that this section, this particular zone is in a good state. And the red one, logically, that is bad and some action is needed. this way, you can integrate the static and the dynamic information at the same time on the same screen. How can it be that inspection data can be mentioned among dynamic and real-time information? It's because our inspection software is in a cloud system. So if I enter a damage into the software, no matter if it's a crack or a wet area or whatever, the client can see at the same time that I entered something, and it can lead to really fast actions. Obviously, the same application has an offline feature, because in Switzerland the tunneling network goes further in the Alps, sometimes the internet network. So we had to be prepared for this option too. But back to the cloud solution, it's obviously an open IPA, so any kind of data format can be used. The basic of it is still the laser scanning, the grayscale pictures that were made from the laser scanning. You can also overlay different inspections and compare the results. It can be very important in the case of the evaluation of the development of the damages. But what I find personally really interesting about this software, it's not just the comparison or the overview over the whole infrastructures and each and every object that we inspected, but and this is the artificial intelligence that works with deep learning by image detection, by image recognition, that can enter instead of us automatically the damages, so I don't have to take time to draw the details of it. On this particular side, you can see the example of cracks in sprayed concrete lining. On the left, the source image, the grayscale picture from the scanning. In the middle, what I would detect manually, and on the right, what the automatic machine made. So you can see it's quite similar, and it makes us work much faster than before. On the next slide, you can see the same analogy, but for wet areas. It's maybe the deep learning tool is maybe a bit more precise. So as for me, I'm very happy to work with this tool. Klaus, could you please summarize what benefits you see in these solutions?
Yes. I'd like to show and summarize the benefits which we obtain by using the digitalization for maintenance processes. Using the digital twin allows us to build one single source of truth. So we can find all the data in this digital twin, which allows then for a rapid problem-oriented data retrieval, but at the same time also to visualize both the static and the dynamic information. With this information, also including real-time information, we can then work on predictive maintenance, as it was discussed today prior. And this allows then overall a reduction of cost, but at the same time to increase the quality of our maintenance. And by that, improve the overall productivity, but also the transparency of our processes. With this, we would like to close our presentation and thank you very much for your attention.
Thank you very much, both of you, Veronika and Klaus, and also on time, which is really great. That gives us the possibility to ask one question, and that's from Nicholas Kuh, and I think that one is for you, Veronika. What are the limits of crack sizes that can be detected via the images?
where I was really amazed when I saw that the cracks under 1 millimeter can also be detected. So really thin cracks can be also detected by the artificial intelligence.
That's good. Then actually a bit ahead of schedule. I don't think that's just good, because that gives us some more time to move on to the round 3 room. As before, we have to leave this room and find the next presentation in round 3, starting at 3:45. So 15:45, round 3. I hope to see everybody back then.
Okay, thank you very much.
Thank you.